Hello everyone. Today we have gathered for the second part of DevOps and its tools. So in the last part we have covered the various tools under DevOps, like various categories, the main three categories under DevOps. Today we are going to start the next remaining four categories. So in the last video we have covered version control, then CI/CD, continuous integration and continuous deployment. Then we have covered containerization and orchestration. So let's start with the video. My name is Shreyas Upasni and I am currently a final year BTech student at MIT Academy of Engineering in Electronics and Telecommunication. So let's start with the video. Today we are going to start with configuration management and infrastructure as code. So in the last video we have seen all of this, like the git and GitHub version control, then continuous integration, continuous deployment, which are the different tools we use under this, Jenkins, then Docker, Kubernetes. All this we have seen. Now in today's video we are going to start with configuration management. So what is basically configuration management means? It is basically involves the automating the setup, configuration and maintenance of servers. So for example, if there is any company, it has to manage many servers. Like there is a one system administrator or a DevOps engineer, he has to manage those server database. So for this problem, configuration management is used. Like we can automate or configure all of the systems in a company by at a time, by a DevOps tool, configuration management. So this is what configuration management is. It is basically automating the setup, configuration and maintenance of server at a time to ensure consistency. Then what is infrastructure as code? So it is a practice of managing and provisioning infrastructure through code and automation. It doesn't work on manual processes. It allows infrastructure to be versioned, tested and treated like software. So this is what configuration management and ISC means. So here there are some key benefits in configuration management and infrastructure as code. Like there is consistency. Like at a time we can configure all of the servers in a database, so it ensures that environments are identical. Then there is reproducibility. Infrastructure can be recreated easily in different environments. Then uh, the this category automates the process of scaling infrastructure up or down. Then infrastructure code can be versioned and tracked also. So these are some of the key benefits using configuration management. So there are some popular tools under configuration management. Under that we have these four tools which are quite popular. Ansible is there. Ansible is basically a simple agentless automation tool which uses YAML language. YAML language is basically human readable language. Like it is very easy to understand YAML syntax, so we can use it easily. Then it has agentless architecture. Like if we have to use Ansible, we don't have to install any other software in target machines. Ansible is quite popular than other these tools. Then there is Puppet. It is also a powerful configuration management tool which uses declarative language to define infrastructure. Some of the key features of Puppet are it gives strong focus on compliance. Then it is very scalable for large environments. Then there is Chef. It is a tool for automating infrastructure configuration using Ruby-based scripts. So as we can see, for all of these tools, there are some certain languages we use. For Chef, it is Ruby-based scripts. Then key features for Chef are it is flexible and extensible, and it has strong community support. Then we also use SaltStack. It is a Python-based tool for configuration management. The key features are like it is used for high-speed communication and event-driven automation. So as you can see, there are specific key features for each of the tool, but among all of these, Ansible is quite popular to use. So these all were configuration management tools. So now we will see what Ansible is in detail. So Ansible is basically a one source automation tool which we use for configuration management, application deployment and task automation. There are certain key concepts in Ansible. So there is a main concept called playbook. Playbook is basically a YAML file which contains set of tasks which we have to perform. Like if we have to run any task for any project, we write playbook, and in that playbook we write these tasks in YAML language so that we can execute these tasks. Then there is a concept called module. It is basically a reusable unit of work that Ansible performs. Like if we have to install a package, or if we have to start any service, these these things we can write in module. Then there is inventory file. Inventory file is basically where we give the location of the host, like where we have to configure the that target machine, the that location we write into inventory file. So this all are the key concepts in Ansible. Then these are all infrastructure as code tools. Like then there is a Terraform. It is an open source tool for building, changing and versioning infrastructure safely and efficiently. There are some key features of Terraform, like it has declarative syntax to use. Then it supports multiple cloud providers, which is a good thing among all these uh, tools. Then it supports state management. Then there is a tool called AWS Cloud Formation. It is a service provided by AWS only for defining and provisioning infrastructure. It uses JSON or YAML templates, so which is very easy to use. Key features are like it is only by AWS only. Then due to that, it supports native integration with AWS also. It supports all AWS services. Then there is Fuelumi. It is basically a modern ISA tool that allows you to write infrastructure code in general purpose programming language. Languages like Python, JavaScript, and Go we can use for in Fuelumi. Key features are like this one only. It uses familiar programming languages, and it also supports multiple clouds. Then there is Azure Resource Manager. It is also called as ARM. It is Microsoft's ISA tool for managing Azure resources using JSON templates. Certain key features are native integration with Azure, as it is developed by Microsoft only. So it has native integration with Azure, and it supports all Azure services. So these were some of the tools in infrastructure as code. Terraform is quite popular. Terraform is an open source ISA tool that allows you to define and provision infrastructure using a declarative configuration language. Some of the key concepts in Terraform are a provider. Provider is basically a plugin that interacts with APIs, application programming interfaces, to manage resources. Like there are some resources like AWS, then Azure, GCP. There are certain resources under these, like virtual machines, then virtual private clouds. So we can manage these resources using a provider. Then there is resource. Resource is basically a component of your infrastructure, as I said earlier. There is virtual machine, there is database, so these all are resources. Then there is a state file. State file basically is a file which stores current state of our infrastructure. So these are some of the key features or key concepts in Terraform. Then the next category in DevOps is monitoring and logging. Monitoring is used for tracking the health or the performance of the systems. The systems like CPU, then memory, then network. We can track the performance of this using monitoring. Then there is logging. Logging basically means capturing and storing system and application events. Then there is alerting, like automated notifications triggered by thresholds or anomalies. Then there is metrics. Metrics is basically quantifiable data points. For example, request rate or error count is there. Then there are logs. Logs are basically text-based event record. records. Like after logging, we get certain set of logs so that it we can use in troubleshooting. Then, for example, service start errors. These are all logs. Then there is a concept called tracing. Tracing is basically end-to-end tracking of requests across services. It is basically used in microservices. So these all are key concepts in monitoring and logging. Uh, in monitoring and logging, there are certain tools which we use for software delivery. Monitoring tools are Prometheus, then Nagios, then Zabbix, then Datadog, then New Relic is there. These all are monitoring tools, and logging tools are ELK Stack, Greylog, then Splunk, then Fluentd, then Loki. These tools we use under monitoring and logging. So under monitoring, Prometheus is quite popular tool. It is basically an open source monitoring and alerting toolkit which is built by SoundCloud. There are some key terms in Prometheus, like there is a target. Which target is basically a service or node which is being monitored. Then there is exporter. Exporter is basically a service that exposes metrics in Prometheus format. Like this is the syntax for it: node exporter for system metrics. Then there is job. Job is basically a group of targets. Like target is a service or node which is being monitored, and job is a group of targets. Then there is a specific query language designed for Prometheus only, which is also called as PromQL, Prometheus query language. It is used to extract and visualize metrics. Then there is Alert Manager. Alert Manager sends alerts based on rules. So these are some of the key terms in Prometheus. Then this tool comes under logging. It is called as ELK stack. Basically, it stands for Elasticsearch, Logstash, and Kibana. It is like a process. Elasticsearch stores and indexes logs for fast search. Then there is Logstash, which collects and processes logs. And there is Kibana. It visualizes the logs in beautiful dashboards. So how ELK works? There are some certain steps it follows. So our app, whichever we app are using, the app or system generates logs. Then logstash collects and processes these logs. These logs are sent to elasticsearch. Then elasticsearch indexes these logs, and then kibana reads these logs from elasticsearch and then shows dashboards, charts, or searches. So this is what basically elk stack does. Then there is a next category in DevOps, security in DevOps, which is also nowadays referred as DevSecOps. It basically integrates security practices within the DevOps process, and it ensures security in a shared responsibility. It also incorporates automated security testing to identify vulnerabilities early in the software development process. Then security monitoring and logging. It implements continuous security monitoring and logging to detect threats in real time. Then there is compliance as code. This concept adopt compliance as code to ensure regulatory requirements are met consistently through all the software development lifecycle, so that there is no harm to security. Then we can use tools like Snake or Zap in CI/CD pipeline for effective vulnerability scanning. So these are some of the key concepts in security DevOps. There is a tool we used in DevSecOps. It is Trivi. It is designed by Aqua Security. It is basically a scanner for containers, as we know, containers, Docker images. Then it scans for file system and GitHub repositories, then Kubernetes clusters. Basically, it scans for OS package vulnerabilities and language specific vulnerabilities in these all uh, things. So this was about DevSecOps. Then the last category in DevOps is cloud providers and infrastructure in DevOps. So there are some key concepts and terms in cloud providers, like which services cloud providers provide. Then the first service is cloud computing. Like we have on-demand access to computing resource. Like we can compute, we can store the data, we can have the networking via internet. So these are our computing resources. Then there is IaaS, which is also known as infrastructure as a service. It is basically virtualized computing resources. We can have example of virtual machines, then storage, then networking. Then there is a concept called PaaS, platform as a service. It is basically a pre-configured platform for app deployment. The tools which we use under this are Heroku, App Engine. Then there is IAC, as we have seen earlier, infrastructure as code. It basically provides provisioning infrastructure using code. It basically uses declarative or imperative language. Then there is multi-cloud service. Like we use services from multiple cloud providers. Like we use AWS, then Azure, then GCP. Then there is a concept called hybrid cloud. It is basically a mix of on-premises, offline servers, and cloud infrastructure. So this is hybrid cloud. Then on this slide, there are some cloud providers and their key service highlights, like which service they provide. Then so first AWS is there. Like AWS provides EC2 instances, then S3 buckets for storage, then Lambda functions for certain tasks. Then there is virtual private clouds. So these all services AWS provides. Then there is Azure. Azure provides virtual machines, then blob storage, then Azure functions. Then there is GCP, Google Cloud. It provides compute engines, cloud storage, and cloud run. Then there is IBM Cloud, which also provides virtual machines, Cloud Foundry. And there is Oracle Cloud, which provides the services for computing, then autonomous database, identity management. So these all are the providers and their services. So these all were the categories under DevOps, under what we have seen certain tools. Now we have came to a conclusion. Like what DevOps does, it basically merges cultural and technical practices for rapid software delivery. Then tools like Git, Docker, Kubernetes are essential in DevOps to have effective software delivery. Then continuous integration fosters collaboration and enhances efficiency in deployment. Then integrating security in DevOps lifecycle is crucial for protecting the data. Then adopting DevOps allows organization to adapt to market changes swiftly and improve quality. So these were some of the conclusions we made from this presentation. So that's for it for this topic for DevOps tools. In the next video, I'm going to cover configuration management in detail. In that video, we will see how to install Ansible, what is configuration management, what tools we use under configuration management, and how we can use Ansible for any project. So that's from my side. We will see in next video. So if you are having any doubts, you can ask in comment section. Thank you.